Hello and welcome to another video. Today we're going to be talking about factoring. So factoring is something they'll teach you pretty early in your math career, and you're going to be using it just for so many different things in the future with a lot of complex processes and problems you'll face always has they'll squeeze factoring back in there some way for you to solve it. So kind of like trigonometry and basic trig problems, it's just sort of something that they'll expect you to know later, and so that's why it's really important to have a pretty good foundation of it. Now there are many different ways you can factor things, um, and I'm going to go over a lot of the ways, especially the more frequent ways, but there are some I won't go over, like kind of long polynomial division, or dealing with just long polynomial factoring with synthetic division. Rest assured, I'll probably post a video about that at a later time, but for now I'm kind of trying to create this intro video sort of as just if you've never really factored before and you don't really understand it very well, this should help you grasp all of the more important elements of it. So if you didn't know, factoring usually involves, again, not always, but it usually involves a trinomial. And a trinomial is just a fancy word for a three-term kind of expression or a polynomial. So for example, you usually have something like ax squared plus bx plus c. And don't worry about these. These are just representing constants. So you'll have some sort of constants in front of an x squared, and then an x, which remember is to the first power, and then a constant. So no x, just the constant. And there are many different ways to factor. Usually there are two ways teachers give it to you. There's what's called this, you're using a square, so it's a square method, and then there's also what's known as the sort of like a diamond method, or later on you just kind of will use tricks to kind of quickly get it. But to give you the idea, let's say we had something like x squared minus 4. And I know it's missing, it looks like it's missing a term here, but rest assured it's not actually. It's just something interesting happens very unique to this type of factoring problem. So let's go ahead and use the square method. So to use the square method, you always put your x square term right here. And remember, this kind of thing with the square only usually works really well when the x squared is alone, and you can actually factor it without other tricks. So that's why the x squared, this method at least of the square, doesn't always serve students perfectly well later on, but it's a really good learning tool. So you put the x squared in this square, always right here, and you put the number right here. So, for example, your negative 4. And I know we don't know what the x terms are going to be, but for now, let's just go and try it. So we know that an x multiplied by an x gives you an x squared. And you can think of the square chart as two things on either side will multiply to give you that thing in each square. So x by x is going to be your x squared, and we also want two things to give you 4. Well, we could do 4 and 1, but for this example that wouldn't work because when there is no x term here, really this is just a 0x, and that makes sense because 0x would be 0 and we wouldn't put that there. So if we're trying to say that they cancel out essentially to give you 0x, what should we do? Well, 4 and 1 do give you negative 4, but we want them to cancel out. Is there anything that cancels out? Well, we know 2 and 2, right? So let's try 2, and for the sake of it, right, negative 2, because we need it first to be negative 4, and that gives you negative 4, so that's good. And if we do 2 and x, that's 2x, and if we do x and negative 2, then that's negative 2x. So as you can see, this works because these the 2x, which is, remember, a plus here, and a negative 2x cancels to give you 0x like we wanted. We have the x squared, and we have the negative 4. So we solved the quadratic, which means that our answer is x plus 2, x minus 2. Now, for this special type of factoring method, which is called a perfect square, you don't have to necessarily worry about dealing with this chart with the square. And although it's a really nice learning tool to see what's going on, at least visually on the surface, it tends to confuse students if it becomes too complicated. So I may use it once or twice more, but just know that this diamond, which it kind of takes the shape of a diamond, but keep in mind that it's really just the same, where it's doing a similar thing. We're just going to be using it in a different way. This kind of shows it visually. But if you notice, and let's see if it makes sense. So ignoring this 0x, because we don't really need to understand it right now since we know it cancels, for this type of problem, is there some sort of thing going on? Like x and x squared and x and 4 and 2? Well, you could make the case that it looks like we're taking the square root, which remember is just, a square root is just the opposite of a square. So x times x, or x squared, is x squared. And if we wanted to go backwards, we would just take the, if we root x squared, then we go back to x. So if that's the case, then if we take the root of x, well, it seems like we get, of x squared, we get x. If we take the root of 4, we do seem to get 2. So let's see if that follows suit with other things. If we take a similar problem, will it work out just the same? So let's see if it does. So if we went ahead, let's say we said something like x squared minus 9. So a very similar thing. What if we take the root of x squared? Well, that again becomes x. What if we take the root of 9, square root? We get 3. Okay, so let's do it again, just the same pattern, the plus in the middle and the minus. Is that the answer? Well, if we did the whole chart again, it would be. So it turns out with perfect square trinomials, or with perfect square expressions, the best way to approach these are to understand that we can use this shortcut almost to get the answer very quickly. I mean, it only works if there's a minus here. If there's a plus, that's not the same thing, and in fact, it doesn't exist. We can't say that's with real numbers. And why is that? Well, because if we said x plus 9, then let's say we set it to 0. Well, if we minus 9, we get x squared equals to negative 9. And if we square root the x and we square root this, well, this is x equals to, wait a minute, this gives you an answer that doesn't exist. You can't square root a negative number. And in fact, what this is going to give you is plus or minus 3i. And the I is just an imaginary number. But when you first learn factoring, they're not going to let you use i's because you don't understand the concept fully yet. So if you have a plus, we know we can't use this trick, nor can we factor it in that way. And speaking of putting onto the other side, so for example, if we had x squared, let's just say minus 9, can we just solve for x? It turns out we can't. We can just solve for x. You don't necessarily have to factor this. Now, after you get really good at this, you probably will, because it becomes really tedious to go through that every time. But when it's just alone with a 1x term and a constant, we can solve for the x, and that's perfectly fine. And we did the same thing, if you notice, because if we solved x minus 3 equals to 0, and we added 3 to both sides, so one of our answers would be x equals to 3, and that's one of the answers we got here. Because when we square root something that we set up, that means that we have to include the plus and the minus version of it. So, knowing that, could you tell me perhaps what, let's just say, what would x squared minus 16 be? And what would x squared minus 36 be? Well, it turns out, kind of like how you might think, that this would be x squared minus 4 and x squared plus 4, because the square root of x squared is x, and the square root of 16 is 4. And this would, of course, be x minus 6 multiplied by x plus 6, because the square root of 36 is 6. So this is one of the more nice ones you might get when it's a perfect square, because You don't have to do too much math with it, just because it does either work out algebraically, or you just can understand the trick for it and get it very quickly. So perfect squares, not too bad. What if we get into something like that thing I was talking to you before, the ax squared plus the bx plus the c? What if we actually have a bx? What if it's not 0x? Well, let's try something like that. What if we tried x squared plus 8x plus 16? So we can't just solve for x because we have more than one x, and we can't take out an x or something like that because there is no x here. So what should we do? Well, it turns out what we want to do here is we can use the square, and it will work out in a way as well. If we put the x squared here, we put the 16, we try to guess with the 8x, we try to split that up, right? We try to split up 8x into 2, then it works out in this case. We'll get x, and then x by 4 gives you this, and x by 4 gives you this, and 4 by 4 gives you 16. So that works out. But sometimes the polynomials get too tricky, and it's difficult to do that with the square. So I'm going to teach you a different way, which you'll end up using quite a bit when you're doing factoring problems, because it's a little quicker and it's a little more consistent. So to do these kind of factoring problems, what we want to do is we want to multiply the constant by the x squared term. So let's try that. So 16 by x squared gives you 16x squared. And we're going to take the middle term, the 8x, and we're going to put it on the bottom. Okay? And what we want to do is we want to find two numbers here that will add up to give me this bottom number. So we'll put an add here to remember that. And we want them to multiply to give us this top number. So I'm going to put a multiplication symbol here so you can see that, and I'll use the classic one. So if we wanted to find two numbers that add up to 8x, well, we could use 4x and 4x. We could use something like really anything per se. So the best way to approach this is to go and see the top number. The multiplication is a little more restricted. So we could use 4x and 4x because that would give you 16x squared. We also could give you 8x and 2x. So if we try 8x and 2x, that's correct. But the problem is 8x plus 2x actually gives us 10x. So we don't, it can't be that one. So let's try that 4x and 4x. So 4x and 4x. Well, 4x and 4x will multiply to give you 16. And if we add them, we'll get 4 and 4 is 8x. So that we know that works. So if that's true, we can actually tell that we get the same thing. So we get the x plus 4 and x plus 4, because what we do is we take the term we get. So I know we said it's 4x, but when we want to take this for the factoring, we would say that it's going to be a 4. So we just take whatever the term was, and we use the x, and we use whatever if it was positive or negative. So since these both were positive, we put a plus right here in the center. So a plus. So if you notice, we get the same thing both ways. We get x plus 4 and x plus 4 if we do it this way, or if we do it the square way. And I recommend trying to use this way a little bit more because it tends to alleviate mistakes and guesswork. It's a little less guessy here. I know you do have to guess for these terms, but it is a little bit less guess-based. So now that that worked, let's try something similar. How about x squared? Let's say something like 7x, and let's say plus 12. Can we use a similar method? I think we can. So let's multiply these two. So x squared and 12 would be 12x squared. And then let's put the 7x, the middle term, on the bottom. So what are two numbers that multiply to give you 12? So we know there's 6 and 2. We know it's 12 and 1. we know it's 4 and 3. So does 6 and 2 add to give you 7? No, they don't. Do 12 and 1? They don't either. Let's say, well, did 4 and 3? Oh, 4 and 3 do. So let's try 4x and 3x then. Well, that gives you 12, and 4x plus 3x gives you 7x. So perfect. I think we have something that might work. So we're going to take again the x, we're going to take the positive, so positive and whatever it was, so 4. We're going to do similar here, x plus 3, and then we have our answer. So it's not too bad to use a diamond way, and it's a little bit quicker than using the square sometimes when you have to write so many things out and guess what the x's might be. It's a little bit more clear this way. So now you have that a lot out of the way, let's try something similar, but it looks a little weird. So let's try something like this. Let's say we had something like 2x squared, let's just say plus 16x plus 32. What should we do here? Because from what I told you before, you need this to be a 1 in front of the x squared for this to work effectively. So what if it's not? Well, there are multiple things that we might have to do, but the easiest thing to try first is to see if we can take out something or a constant so that we can get this to work out. So if we took out a 2, because it looks like we could take out a 2 from the x squared to make it just an x squared, well, we get x squared. Okay, well, taking a 2 from 16, we'll get that that's 8x because 2 times 8 is 16, and the same thing goes for 32. That would be 16. Wait a minute. Isn't this just the same thing I just gave you? It is. So we actually just solved, this is the same expression as this. We're just putting a constant for each of them. So they can give you something like this where it's a similar thing, but the issue is that it doesn't look like it because we have a number multiplied to everything. But remember, the first step is always to take out something and to hope that at some point we can get it into a form that we can easily factor with our trick. Sometimes you won't be able to, but sometimes you will. So what if we didn't have that? What if instead something really odd was going on? What if we had, I don't know, something like, what if we had an x cubed plus a 7x squared plus a 12x? Are we done here? Well, not really. This looks a lot like this, doesn't it? What's wrong with it? Why can't we factor it? Well, this is an x cubed, not an x squared. Well, it looks like we can take out an x, right? So if we took it at an x, that would be x squared plus 7x plus 12. Well, we can do that with this, right? So we already know this part. This part was x plus 4, and then this was x plus 3. But what do we do with this x? Because if the other one we didn't actually have to do anything with the constant, because if we divide it by the constant, well then we get 0 or 1. But this is not the case, right? So what do we do with this x? Well, if you recall, when we're solving for x, we take each term and we equal it to 0. So if we took the x plus 4 and we subtracted a 4 to get x alone on this term, we'd say this is a negative 4 for the x. And if we subtracted negative 3, we'd get negative 3. Well, if we had just x equals to 0, then x just equals 0. So if you ever have an x, if you take out an x, just remember that one of your x values is going to be 0. So in this case, x is equal to 0, negative 4, and negative 3. So a very, very similar problem. Just know that sometimes they can give you problems where we have our basic format, it's just they're going to throw in a constant you have to take out, or an x you have to take out. And there could be multiple x's you have to take out. But if you can get this to a sole x squared term, taking out something, well, we can just solve it like normal, just like now. We just have to remember that sometimes the x here doesn't always go perfectly out of it, and we have to account for it with this 0, for example. So this is all pretty good, but what if we don't have something that can easily be taken out to give you that standard x squared term alone? What if it was something a little weirder, where instead of there being an x squared term or something, what if what if we couldn't take out something? What if the x squared had someone on it, and we couldn't do a thing with it? Well, it turns out there's another way we can approach this, and this is called group factoring, or factor in by grouping, if you want to add a little bit of twang to it. So let's say we had something like this. What if we had something like 5x squared minus 11x plus 2? Could we do this? Well, the first thing you have to realize with factor by grouping is we first want to try to avoid it if we can, because factoring by grouping takes a little longer than normal factoring. Well, is there anything we can take out of this so that each term can be taken out, something so that x squared can be alone? Well, no, we can't, because if we take out a 5, we can't take a 5 evenly out of 11 or 2. So that doesn't work. Okay, well, now we have to try our other way. So the first thing to do is we're actually going to do the same thing we normally would do. We're just going to take account of this constant in front of the x squared. So what would we normally do? Well, we would multiply the x squared by the constant at the end. So 5x squared by 2 would just give us 10x squared. Okay, so far, not too weird. So then we're going to put this, the same thing, we're going to put the middle term down below, negative 11x. We'll make we'll use our diamond strategy. So what numbers could we multiply to give us 10x squared, but add up to give us a negative 11x? Well, we could try 5 and 2. 5 by 2 do give us 10, but we can't get that to equal 11 in any way. So that can't be it. Okay, so let's try another one. How about 10 and 1? So let's say 10x and just x for 1x. Well, 10x and x do give us 10x squared, and 10x and x I think could give us 11. So what if we tried them both negative? Well, negative x multiplied by negative 10x, well, that still gives you a positive number. So, and negative plus a negative does give you a negative 11x. So this seems to work. Okay, so we found two things that work, but we're not done. We can't just say that. A common mistake is to say that, oh, okay, got it. So that means that it's going to be x minus 10 and x minus 1. So unfortunately, you can't say that. That's not the answer. We're only half finished. So what we do is we write the 5x squared the same way. So we take the same expression, we write the 5x squared, but we're going to break up this negative 11x into these two parts that we already found out. And you're going to try to put it together with something you think would evenly take out with each one. So for example, does 10x and 5x, does that seem to do they have something in common? Well, they do, because 5 times 2 is 10. So let's try to put the 5x squared and the 10x together. So we'll put the 10x right here, we'll put the negative x right here, and we're going to put the plus 2 here. So if you notice, all we've done is we've broken up this negative 11x into something that equals negative 11x, but we've used our sort of trick diamond from before. Okay, so what do we do now? Well, we have to take out something such that we can get the same thing on this inside parentheses for both. So both terms should be the same if we take out something. Okay, let's try to take out something. So we know that a 5x and a 10x, we could take out something. But remember, we want them to be the same. So we want this to be closer to this term, since it's the more simpler one. So if we take out let's just say 5x, because we know that a 5 goes into both of these, and an x goes into both of these. So 5x times what gives you 5x squared? Well, that'd be an x. Okay. And then if 5 times what gives you negative 10x? Well, that would be definitely, I would think, a negative 2, because that's what would equal if we went to it. Okay, minus 2. And what if we took something else? Well, how would we get x minus 2? How would we get this to look like this if we wanted this as a negative x plus 2? Well, it looks like we have to take out a negative 1 so that it turns into x minus 2 as well. So if you notice, all we did is we're just kind of creating a puzzle so that we get this and this to be the same as one another. They might have a different thing on the outside, but that's okay. We just want this and this to be the same. Okay, well, once they're the same, we've basically solved the problem. We just have to take this and this and put them together. So we're going to bring down this, and we're going to bring it together, the 5x minus 1, and we're going to bring together the x minus 2. Since we just repeated, we can just put that down here and multiply it. So this is the answer. This is our factored answer. Let's just say we were to solve. So usually we don't have to think too much about it. This would be x is equal to 2 if we move over a 2. Well, here, if we moved over a 1, we get 5x is equal to 1, and then we divide by 5, and we get that x is equal to 1/5. So for things with a constant in front, we have to do a little more math to get what the x value is. But just know the factored answer is this. This is how you would factor by grouping. So it's a little longer than another similar ways, but it's not impossible to do. And we're going to try one more just so that you can kind of see the way to do that. So let's say we had a similar problem. Let's say it was something like 6x squared plus x minus 1. Can we take out anything with this evenly so that x squared is alone? It doesn't look like we can, so we have to actually do factor by grouping then. So let's do the same thing. So if we multiply 6x squared by negative 1, we'll get negative 6x squared, and then we have just x here. So are there two numbers we can multiply to give us 6? Well, I think so. 3x and 2x come to mind first. 3 and 2 give us 6, but we want this to be a positive 1x. So we should put this as a minus 2, so that they add together to give you a positive 1x. Okay, so it looks like we found it. So let's do the same trick. Let's rewrite 6x squared. Let's put 3x right here, and let's put negative 2x, and let's see if we can take out something. If we need to switch them around, we can. Okay, so what can we take out from this one here to make it look like this? Well, we could take out maybe a 3. That looks like it could work. So if we took out a 3x, because they both have an x, just like before, well, that would be 2x. And then if we took out a 3 from here, well, 3x multiplied by 1 would give you that. So it looks like we have a 3x plus 1. And what if we wanted to make this look like this? Well, it's pretty much already there, but it looks like we just need to take out a negative 1. So negative 1 would be 2x plus 1. Okay, we got them to look the same, and we got something on both on the outside. So let's just bring it down. So that would be 3x minus 1. And then we'd have something like 2x plus 1 from our inside. So all we're doing, we're taking out something so that these are the same, and then whatever we get from when we take out these two things, we put them together, and they become the second factored term. So we're just sort of rewriting this into a step-by-step term so that we get it to, once again, equal two terms. And like I said before, once we get the two answers, this is really all we need. But if they asked you to solve for x, you would just algebraically do that just like before. So now I'm going to try to do some other examples for you that you can kind of try out and see what strategy we should use. So if we wanted to use something like this one right here, do we have to use factor by grouping? Well, I don't think so, because we can get the x squared alone. So if we were to take out a 5, we get x squared minus 2x plus 1. And then if we were to factor this, well, what numbers give us x squared? And then add to give you negative 2x. Well, it looks like x and x will multiply to give you this. And if we put negatives on both of them, then we can add them to give you negative 2x. So then we can get that's x minus 1 and x minus 1. So in this case, the answer repeats, but we still factored it in the same way. Okay, well this seems like it works out pretty well. So what if we tried something maybe a little bit interesting? What if we tried 2x squared minus 18? Do we have to do something weird like this? Well, it kind of looks like that first one we did, but there's some terms here. Well, just like we applied from that previous one, we can take out a 2, for example, and then this just becomes x squared minus 9, which we already know to be x squared minus 3, x3 plus 3. So as you can see, there are lots of ways you can do this to give yourself the right answer. So you just have to kind of see what works. So first try to just factor it normally, see if it's a perfect square, see if you can take something out, and if not, you might just have to use factor by grouping to get those two terms.